Well, hello and welcome to this exercise. Now, I've done this before, but I had a note from three of my subscribers some time ago asking me to do this again. So here we are. And it says 3 sine alpha minus 4 cos, sorry, it says 3 sine theta minus 4 cos theta is equal to 2. We're supposed to solve this equation. Right, now what I've done is to write this as 3 sine theta minus alpha. So I'm going to replace this bit. So I'm going to replace the main body of the equation with this bit here. Okay? Why? Because if you have a look at this series of addition formula there, I'm going to use one of these things here to help me solve the equation. And if you look closely, I've got sine. If I call a my theta and so forth, I got sine theta there, and I got minus cos theta. So if I let A be theta, well, in this case, well, it's not truly speaking, that's not the case. So I've got sine A there, and I got a plus there, and I got cos A. But that's not the same as sine minus and then cos. So it's not the first one. Now it's got this one here because I got sine A there, and then a minus, and then cos A. So now I have to try and rewrite my r sine theta minus alpha, because the sine B there, I should try to replace this sine B and the cos B with something else. So now when I expand this bit here, I get something like this one here. Because in this instance now, this is my, if you like, this is my sine theta or sine A in this case here. But my r cos alpha is the coefficient of sine theta, similar to cos beta here being the coefficient of sine A. Again, r cos alpha is the coefficient of sine theta. So in the main equation itself, this one here, the coefficient of sine theta is 3. Similarly, in this one here, the coefficient of cos theta is r sine alpha. So in the main equation, the coefficient of cos theta is 4. So r sine alpha in this case will be the same as the sine B in the addition formula there. So B is not the same as alpha, but r sine alpha is the same as sine B. It doesn't matter, but all you need to know is which one of these to choose for r sine theta minus alpha in this case. Okay, so if I now so r cos alpha is 3 and r sine alpha is 4. So that will be good. That will be the coefficient of the second term, this one here, and that's the coefficient of the first term, this one here. Okay, you don't mix up the coefficients, by the way, or you get it wrong. So if I now draw a triangle, this triangle here, I've got that r sine alpha is equal to 4 and r cos alpha is equal to 3. If you divide sine alpha by cos alpha, you get tan alpha. But r sine alpha is 4 and r cos alpha is 3. So now we are now in a position to expand this bit here, and we don't have that there. So r will be the square root of the coefficients 3 squared plus 4 squared, and that gives us 5. And tan alpha is going to be 4 over 3, which means alpha is 53.13 degrees. Now, I've used the value of alpha in the first quadrant. I know that this here is positive. The temptation is to try and find the other alpha value in quadrant 3. So I use just the alpha value in the first quadrant in this case. Okay, right. So we then have that 5, which is r, sine theta minus 53.13, which is the alpha, is equal to 2. So if we divide both sides by 5, we end up with sine theta minus 53.13 is equal to 4. Sorry, is equal to 0.4. Now, in this case, you have to use all the possible values of the angle that gives us a sine value of 0.4. And because 0.4 is positive, we have to use both the angles in the first and second quadrants. Okay, so that will then give us values of 23.58 and 156.42. And by simple arithmetic, you end up with the first theta value being 23.58 plus 53.13. You get the answer 76.71 degrees. And the second theta value is going to be theta minus 53.13 is equal to 156.42, which I got from there. And that gives a theta value of 209.55. Now, in the exam, you don't have to do all of this. You need to know two things: how to find the tangent of alpha and how to find r. In this case, you find the tangent of alpha by dividing the coefficient of the second term by the coefficient of the first term. In this case, 4 over 3. So that's all you need to find alpha there. Okay? And to find r, you find the square root of the sum of the squares of the coefficients. 4 squared plus 3 squared. And that gives us 5. So all you need to do really is to bear in mind what your coefficients are. You don't have to go through everything I've done here. And secondly, you need to use the principal value as the value in the first quadrant to help you out there. Okay? Now, with all that in mind, can you have a go at these now? Now, oh, don't forget that here, where we got, for instance, you got sine or cos beta there, got sine beta there, sine b there. Now, b is not the same as alpha, but r sine alpha is the same as sine b, if you see what I mean. Okay, so get very careful there. Okay, right. So this is just an example to try illustrate how I use my addition formula there. Okay, now why don't you have a go at these now? It says solve the equation 4 sine theta plus 3 cos theta is equal to 5 for theta values between 0 and 90 degrees. Now, you have to decide which of these here you're going to use. Now, I got sine theta plus cos theta. Now, sine theta, that's minus there, so that's no good. So I've not got sine theta there, so that's no good either. I've not got sine theta there, that's no good. So it's got to be this one here, sine A plus cos A. So I got the plus sign there. Okay, so I'm going to use this. I'm not going to say R into sine A plus alpha, and that's what we're going to use there. That you replace all that. So you replace theta with A, and then this equation will be similar to this one here when it is expanded, and that's what you got there. So in effect, you got that. You got that R sine A cos alpha plus R sine alpha cos A. That's equal to 5. So the answer you expect for this equation there is 53.13 degrees. Now try it yourself. Now the second one is this one here. 3 cos A minus 2 sine A is equal to root 13. Now I got cos A and minus sine A. So I'm looking for cos A minus sine A. So it's going to be this one here, cos A and minus sine A. So I'm now going to use R cos A minus alpha. So I'm going to use this one here. So it's going to be R cos A minus alpha. You then expand. Now the answer is easy for this one. Now for the next exercise, try this one here. And that says 10 cos A plus 7 sine A. Now I got cos A, and I got sine A there. Cos A sine A. Right, so I got cos A and sine A, but this sign is negative there. So it's not that one. Now here I got cos A plus sine A. So I'm going to use this one here. So I'm going to write R cos A minus B. Sorry, R cos A minus alpha is this one here. Okay, so now for this one, the value of theta is 3 divided by 4. Don't forget, is the coefficient of the second term divided by the coefficient of the first term. In this case here, the value of R will be the square root of 4 squared and 3 squared, which will be 5. In this case here, the tangent of alpha is going to be 2 divided by 3. And R is going to be the square root of 2 squared and 3 squared. The sum of the square root of 2 squared and 3 squared. Okay. Now in this one here, the tangent of alpha is going to be 7 divided by 10. It's always the second coefficient, sorry, it's going to always be the coefficient of the second term divided by the coefficient of the first term. So it's going to be 7 over 10. And R is going to be 10 squared plus 7 squared, and you find the square root. So in order to solve any of these equations, all you need to do is to find tan alpha and the value of R. That's all you need. And you get both from the coefficients of the terms. Now, I hope all of that made some sense, and please subscribe. Thank you for watching, and bye-bye now. Bye-bye.